Alright, we're going to look at how to sketch a ray diagram for two mirrors. We're going to look at one for a concave mirror. We're going to look at one for a convex mirror. So we showed you how to draw three different rays. At the end of the day, you only have to be able to draw two of them. So we have this object here. Again, all our objects we're going to represent as upright arrows. And we want to determine the characteristics of the image. So we're going to look at its magnification, attitude, position, and type. So as I said, the ray diagram is meant to be a real rough answer. It's not meant to be very exact. So the first ray that we can draw is we can draw that first ray, we can draw it parallel with the principal axis, and then when it reflects, it's going to pass through the focal point. So I want to draw the incident ray here. We're going to draw it and try to draw it as parallel as you can with the principal axis. So there is my incident ray. Now it's going to reflect off the mirror, and it's going to reflect such that it passes through the focal point. So we just want to get through that focal point. So this is my reflected ray. We're going to do the same thing now with the second ray. Instead of going parallel to the principal axis, we're going to pass it through the focal point this time. So and again, we're doing it all from the tip of the arrow. So from the tip of the arrow, we're going to pass that through the focal point. We're going to try that again. We're going to pass it through the focal point there. So this is my incident ray. It's going to go from the tip of the arrow to the surface of the mirror. Now, based on our rules, when this reflects, it's going to reflect such that it's parallel with the principal axis. So we're going to have something that looks a little bit like this. And it's not going to be the most accurate because I don't have a grid to help me with this, seeing if it's parallel. But we'll have something that looks like this. So this is my reflected ray. Now, we're looking at the intersection of the reflected rays. So for the reflected rays, what we should notice is we're going to notice that there's an intersection at this point here. So at that point there, this is going to be the tip of the image. So that tip of the arrow that we had in our object, this is going to be the tip of the image here, the same tip of that arrow. So we can just kind of sketch out our arrow again. There's our tip at this convergence point, and there's our lovely little arrow there. So this is the image that we formed. Now we want to ask ourselves some questions. So magnification, you'll learn a bit more. You'll learn more about it with distances later. But one thing that we can look at is we can look at kind of the vertical size of the image. With respect, comparing the image to the object, is it larger vertically? Is it smaller vertically? Is it the same size? Now, most times you'll be able to eyeball this. If you can't eyeball it, you can take a ruler. So like if I look at this object, it's got a height of about, I don't know, about 0.6 centimeters. But if I take the height of this thing, it's almost 1.5 centimeters. So my image is bigger than my object. So we're going to say that for the magnification, it's enlarged. If you want to say bigger, that's fine too. That also works. In terms of attitude, you'll notice that my object is pointing up, but my image is pointing down. So with my image pointing in the opposite direction to my object, we're going to say for the attitude, we're going to say that it's inverted. The big trick where they'll try and get you on an exam is if your object was pointing down and your image is pointing down, we always think down as being upside down, but if your image and your object are pointing in the same direction, that is going to be upright. So be careful with that one. In terms of position, for the ray diagrams, we can't be too exact with this, so I'm just going to say for the position, we're just going to say it's located out here. We're just going to say it's beyond C. That's all we can say. When you do the math, you'll get an exact answer for that. But for the ray diagrams, we're just doing a bit of a rough calculation. And then for the type, well, we have real rays that are converging. This is going to be a real image. Another way we could say this, because it's real, so the image is on the same side of the mirror as the object. So the image and the object are on the same side of mirror. So on the same side of mirror. That's another way we can tell if it's a real object. But the more formal way of saying that is it's the real light rays that are converging, hence this has to be a real image. So as I've seen in my time, students can usually sketch concave ray diagrams for concave mirrors pretty well. There's kind of one little tricky one which we're going to deal with separately. We'll get to that later. It's the it's the convex mirrors that get people all the time. But we'll take it nice and slow, nice and methodically. No need to rush this. So here's our object this time. And we've identified this virtual focal point and this virtual center of curvature kind of on the opposite side of the mirror. Now, the first ray we can draw it parallel with our principal axis. So we're going to take it from the tip of this arrow, and we're going to draw it parallel to our principal axis, and we're going to draw that until we hit the mirror. So we're going to draw that to the mirror. Now, this ray is going to reflect off the mirror, but it's going to look like it originated from this virtual focal point. So what we want to do is we want to extend that light ray all the way back to this virtual focal point, but we're going to do it as dashed lines because they're virtual rays. And then this is going to reflect as a real ray. So we can kind of see that this dashed line is an extension of this reflected ray. So this is going to be my virtual part of the ray. Here's my real part of the ray. The second ray that we can draw, you have two options. You can do ray 2 or ray 3. I would recommend drawing towards the center of curvature, because if we try to line up our ruler such that we're getting to the center of curvature, we have our reflected ray, we have our incident ray, and then it's going to reflect back along this path, but then we can extend that virtual ray behind the mirror. So we have our incoming and reflected rays, and then we have the extension of that reflected ray. And we'll see behind the mirror, we can also actually see that this point, there's a convergence of our points here. So where these points converge, that's going to be the tip of my arrowhead. If we did all the light rays from the tip of the object, well, where they converge, that's going to be the tip of the arrowhead. So this little arrow here, that is going to be my image. So let's assess its characteristics. Well, this is certainly much smaller in height than the object, so the image relative to the object, it's diminished, or smaller, however you want to phrase that. And when we're talking about magnification, we're always looking at the image relative to the object. The attitude, they're both pointing in the same direction, they're both pointing up, so we're going to say that the image is upright. In terms of position, again, this is going to be very loose. We don't have anything really exact. We'll just say it's between the mirror and the focal point, or between mirror and FC, or FV rather. Don't worry too much about the exactness. And then the type. So the type of image, this is formed with the convergence of virtual rays. This is going to be a virtual image. The other way we could say this is the image and the object are on opposite sides of the mirror. That's another way we can identify it as a virtual image. So when we're doing ray diagrams, as I mentioned, the ray diagram is not meant to give you an exact answer. It's just meant to be like a rough check or like a plan B. I'll show you a special case in the next video, and the special case is what they really try and ask on the diploma quite a bit.